In this video, I'll introduce partial parsing. I'll provide some background intuition and then describe an approach to partial parsing called chunking and explain how it's performed. The methods we've seen so far have all shown how to compute full hierarchical constituent trees for your data. Full parse trees are highly useful for some tasks, but for many others, they may not be necessary. A lot of NLP tasks can be completed effectively using simpler parses, reducing the complexity and time necessary to build downstream applications. When all we need are these simpler parses, we can do what is called partial parsing or shallow parsing. There are a variety of ways in which one can generate a partial parse, but a common way is through a technique called chunking. Chunking is just what it sounds like. It's a method for breaking text into chunks, and those chunks represent the different non-recursive, non-overlapping constituents in the text, like basic noun phrases, verb phrases, prepositional phrases, and adjective phrases. This means that the result you end up with isn't a full recursive hierarchical tree, but instead a flat, segmented representation. The process of extracting chunks from text can be broken down into two fundamental tasks: segmentation and labeling. For the first task, the system's goal is simply to identify the non-overlapping, non-recursive, sort of fundamental phrases in the text. For the second task, the system's goal is to take those fundamental phrases and predict constituent labels for them. The actual definition of a chunk can vary somewhat depending on your task, but in general, chunks should not be recursive. That means that if a segment could be contained in a production rule, like noun phrase generates a noun phrase followed by a prepositional phrase, and that prepositional phrase generates a preposition followed by a noun phrase, then it would be invalid, and you need to break that segment into smaller chunks. When you encounter constituents like that, a simple heuristic that is often used is to keep the head word of the constituent, so a head word in a noun phrase would be, for example, the noun, and then keep all of the words belonging to the constituent that occur before the head word in the text sequence. This results in a few odd quirks, like the fact that prepositional phrases are usually just left as single words, but it eliminates a lot of annoying attachment ambiguities that could otherwise occur. To break the input text into segments or chunks, systems usually perform what's called IOB tagging, where I stands for tokens inside the chunk, O stands for tokens outside any of the chunks, and B stands for tokens beginning a chunk. So a B, an I, or an O is predicted for every single word in the input, and this process is usually framed as a sequence labeling task. If we were tagging all constituent types, that means we might end up with something like this, where we start with a three-word chunk, her new order, where her begins the chunk and new and order are inside it, followed by three one-word chunks of face masks and arrived. In the previous example, we didn't have any OTags because every word belonged to a constituent, but that doesn't have to be the case. If we were instead looking for only noun phrases in the same sentence, we would end up with something like this, where both of and arrived are outside any constituent. Finally, to evaluate chunking systems, we just use our standard text classification metrics: precision, recall, and F-measure. Overall, chunking is a nice, well-established way to perform partial parsing when you don't need a full hierarchical parse tree.